this is a review of number lines, and so this is stuff that should be prior knowledge, should be familiar to you, probably from the previous course, Math 246. And so I want you to watch this, think about it, take notes, make sure that this is part of the knowledge you're bringing to class next week. So the first thing I want you to know about is an open number line. So an open number line is a number line where you don't put on every single number. So you don't draw out every single tick mark for every single number. You put on just the pieces you need. So I guess we're going to just look at the whole number examples today, and we're going to extend those to negative numbers next week. So we're going to start at 0 because this is a whole number, open number line. And then I'm going to do things with it. So here I'm going to show 7 plus 4 on this open number line. So what do? I show that I'm going to go up to 7. So I'm drawing some sort of a jump or a bar or a representation that says I am increasing by 7. And then I'm going to add on 4 more. So I'm going to go 4 more to the right. And so I have to notate somehow that this is jumping me up by 4. And where I land, of course, is the sum. 7 plus 4 is 11. That's my sum. And so I'm going to always circle that number that represents my answer, what I'm looking for in my problem. Because sometimes that what I'm looking for could be a different one of these numbers in a different place on this number line. So let's look at the subtraction. So addition is pretty straightforward. We're going to do some subtraction. I'm going to do 7 minus 4, and I want to do 7 minus 4 two ways. So I want to remind you that we have kind of two basic notions of what subtraction is. All right, and so these come from the two direct modeling strategies for subtraction. So one of the direct modeling strategies and one of the basic ideas is a takeaway. And so when I'm talking about direct modeling, I call it taking away. And when I write a word problem, I call that a separate. And this is going to be a separate result unknown. So that's what I'm going to call it when it's a word problem. If you do not recognize that term, separate result unknown, maybe you did Math 246 somewhere else that used different vocabulary, would you please shoot me an email so that I can give you some more resources so you have the same vocabulary that we're using in this class. So a separate result unknown problem would say I have 7 apples and I give 4 of them to my friend. How many do I have left? So I am separating some of the amount out. And so I would say that one of the more typical ways, if I was going to try and draw a number line to make that easy to see, I would say, okay, I am going up by 7 on my open number line, and then I want to go back by 4. All right, and so where I end up after I go back by 4, that is my answer. So that's a separate picture. The other way of thinking about subtraction that you should have in your brain, right? So we go back and forth flexibly between two ways of thinking about subtraction, is compare. And so both the direct modeling strategy and the word problem type are called comparisons. So I'm going to say compare, and when I say talk about the kind of word problem, it's going to be a compare, and I'm interested in knowing the difference. How much do those two values differ by? So this is a compare difference unknown. And that's more CGI vocabulary that if it's not familiar to you, let me know so I can send you some resources. And so a compare problem, I have two amounts. So kind of my typical picture for a compare problem has a 7 and a 4 side by side, and I want to know how much is the difference between them. If I was going to tell you a word problem, I would say I have 7 red apples and 4 green apples. How many more red apples than green apples do I have? So that would be a compare difference unknown question. And if I'm going to do that on a number line, so if I'm looking at a compare question, and I'm looking at it with a number line, then what I'm comparing is this value 4. Oops. I wanted to draw, not erase. This value 4 and this value 7. And I want to know the difference between them. So here's my value 4. And here's my value 7. And I want to know how much more is 7 than 4. And so in this case, the answer is the amount of the jump. So when I'm doing a compare interpretation of subtraction, my amount of the jump is the solution on my number line. So that turns out to be a really useful way to think about subtraction sometimes. We're going to definitely get to some multiplication and maybe even some division next week. So I'm going to go ahead and put in a multiplication example and a division example. So here I have a multiplication, and when I have 3 times 4, I can interpret that, because multiplication is commutative, I can interpret that in 2 different ways. So I can either look at that and say, I have 3 groups and 4 in each group. Or I can say there are 3 in each group and there are 4 groups. And the way that I'm going to do this for this class, mostly because I know the kinds of mistakes that it's easy to make later on, is I am going to say that this first number is going to tell me how much in each group. And this second number is going to tell me how many groups. All right, so here I'm going to say that I have 3 in each group. So every time I jump, I'm going to jump by 3. And I have 4 groups. And so I have 4 jumps. Each jump has 3 in them. So this is a repeated addition way of thinking about multiplication. Repeated groups. And there are other ways to represent multiplication, and this isn't always the best way to represent multiplication. This is probably the most common way to represent multiplication using a number line. We might talk about some others later. Let's do the backwards version of that. So the backwards version of that is division. And for division, I'm going to do 12 divided by the amount in each group. Now when I do 12 divided by 3, I can be thinking of 12 divided into 3 groups, or I can do 12 divided into groups of 3. And in terms of direct modeling and in terms of mental arithmetic, trying to figure out that answer, the one that is easiest on a number line is to think 12 put into groups of 3. And so that's the one I'm going to model for you right now. We might come back and do the other ones later. So here I'm going to say I want to get up to 12. How many groups of 3 is it going to take? I'm going to go up by 3 every time. How many is it going to take? 1, 2, 3, 4 groups of 3. So that is measurement division. There's also partition division. But measurement division is the one that we use most often when we're doing representations on a number line.